One common utility of acetals is using a cyclic acetal as an aldehyde or ketone protecting group. So for example, if I take any ketone, this one happens to be a cyclic ketone, but any ketone, and react it with a diol and the presence of an acid. This particular acid is para-toluene sulfonic acid. Looks like this, but primarily just know that it's an acid. What's sort of neat about this is instead of adding two molecules of alcohol like we did before with two methanols, both equivalents of alcohol are in the same molecule. So we have the first alcohol, the second alcohol, and if we add the first, and let's just highlight them to help us keep track. I'll highlight one in yellow, and one in pink. So let's add the yellow one first. When we add that, and it follows the same mechanism that we did before, so really nothing new there. You would protonate this oxygen with the acid, then add the lone pair of the alcohol in, and eventually you get to the hemiacetal. So we get the OH, right, so here's the oxygen I highlighted in yellow. Here's the one in pink. So this is the hemiacetal, but then this will continue to react in the presence of the acid, and eventually this particular diol gives us a 5-carbon cyclic acetal. Here's our two oxygens. This acetal, along with the 6-carbon cyclic acetal, where you would just have one more CH2 in between the two alcohols, this serves as a really good ketone or aldehyde protecting group. So what that means is we can convert an aldehyde or ketone to the cyclic acetal, but what's useful about this is we can remove that cyclic acetal as well. So all you need to do is add acid and water to this. And effectively, by adding all of the water breaks this acetal apart and does what's known as a hydrolysis, and it essentially does the reverse reaction. So this is effectively the deprotection step. Here's an example of how we might use a cyclic acetal as a protecting group in synthesis. So we want to do a particular reaction here where we're adding phenylmagnesium bromide, but selectively the phenyl group is adding to the ester. So we're getting the two phenols added here, but we don't want to touch the ketone. So what we need to do is protect the ketone so it doesn't react with the Grignard. So to protect that ketone, what I'm going to do is add the diol and the para-toluene sulfonic acid. And this reaction is exclusive to aldehydes and ketones, so it's not going to do anything to the ester. Right, so I'm going to redraw this, turning my ketone into the cyclic acetal. Again, this was our protection. Now we'll do the desired reaction. Phenylmagnesium bromide followed by dilute acid. And the phenylmagnesium bromide is going to add the phenyl group twice to this ester to give us the alcohol. So there's our desired reaction. Now in reality, and this is a good thing, step 2, the dilute acid, is acid and water, which will probably go ahead and take this acetal off. And that's what we want to eventually happen anyway. But just to have clear delineated steps, I'll go ahead and do the deprotection where we add acid and water. And that hydrolyzes that cyclic acetal to give us the ketone, and then of course the diol back out.